Hi everyone, good evening. Just want to share one major important update. So today is the last date to apply for IIMB UG, IIMB UG course. So do apply for it. Today is the last date. As per the website, it's mentioned that 20th November 2025. It started from 14th October 2025, and the last date it is today, 20th November 2025. So if you have not applied for IIMB UG, I'll definitely suggest you to apply for this program. If for some difficulties being faced by some of the students. So what you have to do is basically first you have to pay the fees, and after paying the fees you have to come back again and submit the form. Basically you have to fill in the details, whatever details you are being asked for. You have to first pay the fees and then you have to submit the form. So one major important update, as I have already shared, that today is the last date. If you are interested in giving this examination, and I would say it should be, if you are planning for good undergraduate course, this is a very good course to go for. I'll definitely suggest you to apply for this course. Today is the last date, and some difficulties are being faced by some of our students. So basically the procedure is, you have to first pay the fees. You have to visit their website. You have to pay the fees there after registering. Then you have to come back and submit the form and fill in all the details. So you have to pay the fees and then submit the form and fill in the details. Let's wait for 1 to 2 more minutes. I can see a few people are still joining in. So let's start the class. So the topic for today's session is matrices. So matrices is something which you might have not studied up till now. If you come from if you are studying it from the first time, so this is not very familiar topic. It is often considered as a tough topic, or like if you see the previous year questions for, let's say, IPMAT or some other UG program examinations, the questions can be tricky, but if you understand the concept, you will get this. The questions are not very difficult. If you know the concept for how to solve that particular question, you will definitely be able to crack the question. So we'll start with the very basics, from what is matrices and what are different types of matrices, how is operations are performed on matrices, and tomorrow we have determinants class. Today we'll just keep the class of matrices. So let's start today's class. Before that, I just want to update you regarding our IIM Bangalore UG mock test, UG mock series. So we are providing 5 free mock tests. You can just visit, you can just Google search IIMB UG mock test Cracku. IIMB UG mock test Cracku. You search this and you will be redirected to the website. There you can find five free mock tests which are created by the alumni of IIMA, IIMB and IMC. So these mocks are created by the alumni of top 3 IIMs. So I'll definitely suggest you, since this is the first year, and the good idea about how can the actual paper be will be the people who have already studied there. So I'll definitely suggest you that you should definitely attempt these mocks, these 5 free mocks. These are available for free of course. So do give these mocks. You will see what can be asked in the examination. Apart from it, we are running live streams from, I think, from last month up till now. We have covered, I think, more than 25 classes. This is the schedule for the upcoming classes. So these are the classes which we have discussed in the previous days. Today it is matrices. Tomorrow it is determinants. And then we have calculus. Again, from now on, we are bringing a lot of important topics which has a very high probability to come in examination. So matrices, determinants, then calculus, majorly the limits function, or what is continuous function, or how to do that, how to take the derivatives. This will be discussed in the next coming classes. Tomorrow we have determinants, and then one very important section which is logical reasoning. It's a bit tricky, but you should have a lot of practice to get this to ace this section. So I'll definitely suggest you to subscribe to our channel. This is updated every day. We are coming live every day, and we are teaching topics, all these topics, all the relevant topics which can be asked in the IIM Bangalore UG mocks, IIM Bangalore actual UG examination. So keep subscribe to our channel, and do give us a like. We are doing all this for free. We just want you to perform as good as you can. All the content is available for free. You can visit the cracku.in website and search for IIM B UG there. You will find that we have put it in a lot of content, and we are putting a lot of content. Just one like gives us a lot of motivation to do the same work and continue with this work. So I'll definitely suggest you to subscribe to this channel to be aware about updated about all these topics and all the classes, as well as one like is a motivation for us to do like a session. We have also have WhatsApp channels. The link for these WhatsApp channels is in the description box. We have created this WhatsApp channel so that all the like-minded students, basically all the people who are preparing for IIM B UG are together, and they can discuss about what can be what examinations, what can be the in the next few days. I think they are about to release the mock. Official mock is about to being released. So I'll definitely suggest you to join this WhatsApp channel. We'll update about everything which will be coming from IIM B UG. So do join the WhatsApp channel. If you have any doubts regarding these three, you can ask. Again, I'll definitely suggest you to subscribe to our channel, as many of the classes are coming in. And one thing which I want to reiterate is today is the last date to apply for the form. I can see some people have joined in now. So I just want to make them aware about this, that today is the last date to apply for IIM B UG. Today is the last date for IIM B UG. So if you are serious about this examination, or if you are looking for a course for your undergraduation majorly, you should definitely apply for IIM B UG. So let's start about the matrices part from today, from here. So first of all, what exactly is a matrix? So a matrix is a rectangular arrangement of numbers. Just a moment, guys. I'm not able to change the color of this pen. स्ट्रोक पे क्लिक करके कुछ नहीं हो रहा. Okay. 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 Am I audible now? So I had some issues regarding my pen. I'm very sorry for that. Am I audible? If someone can just confirm this. I was not able to change the color of the pen. It was black. I have to switch it to white, which I didn't know. Okay. Can somebody please confirm that am I audible or not? Okay. Okay. Thank you, Ayati. Thank you, Bhavna. So let's start the class. We'll start from the basics as mentioned. So what exactly is matrix? So matrix is a rectangular arrangement of the elements. Rectangular arrangement of numbers, symbols or expressions. So you might have seen something like this. So A, B, C, D, E, F. You might have seen these kind of structures somewhere. This somewhere which is used in a lot of things. Maybe if you go for let's say about statistics or some computer related fields, every data is stored in this format. It is stored in a matrix format. All the data, even if you see even let's say a simple thing like let's say smiley. So smiley is made up of bits. So all these bits information is stored in the form of zeros and ones, and these zeros and ones are stored in the form of matrix. So this is what exactly matrix is. It is a rectangular arrangement of number symbols. So it can be like this, or let's say it can be like A, B, C, D, E, F, G, H. So this is also a matrix, this is also a matrix. Then we have elements are arranged in rows and columns. As you can see, there are 2 rows here and 3 columns. Similarly in this, there are 4 rows and 2 columns. So all the elements in a matrix, so it is like this. So there are many rows and columns. You might have seen this structure. This is a very common structure. So elements, you can see this is a matrix and all the elements are structured as rows and columns. So there are 5 rows and 4 columns. So all the elements are arranged in rows and columns. Then it is represented as Aij. So every element is represented as Aij, where I represent the row number and J represent the column number. So if I say, let's say this is my matrix this is my first row and this is my second row. Similarly, this is my first column, let's say this is my second column and this is my third column. My matrix is like this. So this particular cell is A11. That is the element of first row and first column. This is A11, element of first row and first column. Then this cell is an element of first row and second column, which is A12, first row and second column. Then this one again, this is first row and third column. So this is A13. So as I mentioned, Aij. So this I is the row number and this J is the column number. So this is A11, this is A13. Similarly, if I discuss about this one, this is the second row and the first column. So this is A21. If I discuss about this last cell, this one is second row and third column. So this is A23. So this is what I meant by every element is represented as Aij, where I is the row number and J is the column number. So a matrix has m rows and n columns. It is called an m cross n matrix. So let's say this has 1 and 2 rows, this has 2 rows and 3 columns. So this is a matrix of 2 cross 3. This has 2 rows and 3 columns, so it is a matrix of 2 cross 3. Similarly, if I discuss about this one, this has 1, 2, 3 and 4. 4 rows and 2 columns. 4 rows and 2 columns, so this is a matrix of 4 cross 2. So M cross N, where M represents the number of rows and N represents the number of columns. So it is an M cross N matrix. So it is used to represent and solve system of equations. Majorly to find out how many solutions of an equations are there, we can use this matrices, transformations, data structures and more. There are many applications for matrices. One is basically the storing of bits, and nearly all your data is stored in a form of matrix. So it has a lot of applications. So if you have any doubt in this, you can ask. Okay, so let's move to the next slide. Now, two very important parts of matrix is basically what is the order of matrix. What is the order of matrix and what is the trace of the matrix. So what exactly is the order of matrix? So order of matrix is same as we represented as what is M cross N. So number of rows, M was the number of rows and N is number of columns. M is the number of rows and N is the number of columns. So this M cross N matrix is this M cross N is basically your order of matrix. That is the number of rows cross number of columns is your order of the matrix. So in this example, this first example, we can clearly see this has 2 rows, 1 and 2, and this has 3 columns, was column number 1, column number 2 and column number 3. So this has order of 2 cross 3. 2 is basically the number of rows and 3 is basically the number of columns. So 2 cross 3 is the order of the matrix. Similarly, if I discuss the second example, it has 1, 2 and 3 rows. So it has 3 rows and number of columns is 1, 2, 3 and 4. So there are 3 rows and 4 columns. So what is the order of the matrix? Order of matrix is M cross N, where M is the number of rows and N is the number of columns. Therefore, order of this matrix will be 3 cross 4. 3 cross 4, where this represents 3 represents the rows, which is 1, 2 and 3, and 4 represents the column, which is 1, 2, 3 and 4. So 3 cross 4 is the order of the matrix. Then we have the trace of the matrix. The trace of a square matrix A is the sum of its diagonal elements. Basically, square matrix is something which we will discuss this further. What exactly is square matrix? Square matrix is which has equal number of rows and columns. That is, number of rows and number of columns are same. So for all the elements which have same number of rows and for all the matrices which have number of rows and columns equal are the square matrices. Let's say if it is 1 cross 1, it is a square matrix of order 1. Or let's say if it is 2 cross 2, that is 2 rows and 2 columns, it is a square matrix. 3 cross 3, 3 rows and 3 columns, it is a square matrix. So what exactly is trace of matrix? Trace of matrix is the sum of its diagonal elements. Now let's say if it is a 3 cross 3 matrix, so which means, let's consider this thing. This is a 3 cross 3 matrix. It has row 1, row 2 and row 3 and column 1, column 2 and column 3. What exactly is trace? It's the trace is basically the sum of the diagonal elements. This one. The sum of these elements, or it is also represented as sigma A I from I is equals to 1 to n. So this is the trace of the matrix A. I think this is visible. I hope this is visible. Okay, yeah. So this is AII. I'll write it somewhere here. Okay. Summation of AII from I is equals to 1 to n, where n is basically the number of rows or number of columns. Since it is a square matrix, the number of rows and number of columns are same. So n is basically the number of rows or columns. it starts from A, I is equals to 1 to n. So it becomes trace of matrix is A11 plus A22 plus A33 up till so on till ANN. What is A11? This element is A11. What is A22? This particular element is A22. Then what is A33? This particular element is A33. So A11 plus A22 plus A33. So this is the trace. Let's say if it is a 4 cross 4 matrix. Let's say it is a 4 cross 4 matrix. If it is a 4 cross 4 matrix like this, so there are 4 columns and 4 rows. So there are 4 columns and 4 rows. So what will be the sum? What will be the trace? Trace will be A11 plus A22 plus A33 plus A44. What exactly element is A11? So element, this is A11, that is row 1 and column 1. Then this is A22, row 2 and column 2, so this is A22. Then row 3 and column 3, this is A33. Row 3 and column 3, A33, and this particular element, which is row 4 and column 4, is A44. So the sum of all these elements will be the trace of matrix. So this I have taken an example as well. So for this matrix, if we have to find out the trace will be, so this is my first column, second column, third column and fourth column, and this is my first row, second row, third row and fourth row. So the trace of this matrix will be A11, that is the element of first row and first column, plus A22, that is the element of second row and second column, then A33, which is the element of third row and third column, and plus A44, which is the element of fourth row and fourth column. The trace of matrix A is 4 plus 5 plus 9 plus 6. So 4 plus 5 plus 9 plus 6. So this is 9, 9, 18, 6, 24. So the trace of matrix A is 24. If you have any doubt regarding this one, you can ask. Okay, so let's move to the next slide. Now we have one important thing which is not directly asked regarding this, but these are somewhere referenced in the questions. So this is types of matrices. So there are multiple types of matrices. So we have multiple types of matrices. So first one is equal matrices. So matrices that have the same order as well as the corresponding elements are equal. So let's say this is a matrix. One of your matrices 2, 1, 4 and 3, and your second matrix is also 2, 1, 4 and 3. So these two matrices are equal matrices. Why? You see the order of this matrix is, as I said, the order is number of rows cross number of columns. So number of rows is 2 and number of columns is 2. So order of this matrix is 2 cross 2 and order of this matrix is also 2 cross 2. So order of both the matrices are 2 cross 2. Now if we compare corresponding elements, that is, if we compare the element of first row and first column of both the matrices, it will be same. So we can see first row, first column, it is same. First row, second column, the elements of both the matrices is same. First row, third column, first row, fourth column, again first row, third column, first row, fourth column. So all the elements of the matrices are same. Thus the order is same as well as the corresponding elements are also same. Let's say if the order was 3 cross 3, it was a 3 cross 3 matrix, then it cannot be an equal matrix. If this one is 2 cross 2 and this is 3 cross 3, the orders is different, so it cannot be a equal matrix. Similarly, if I say instead of this 3, this is let's say 5. Now 3 elements are matching. A11 is matching with B11, A22 is matching with B22, A12 is matching with B12, A21 is matching with B21. So 2, 1 and 4 are matching, but this A22 that is in first matrix, which is A, it is 3, but in B this element is 5. This element is 5, so 3 is not equal to 5, so this won't be an equal matrices. So this is about equal matrices. Then next we have is row matrices. As the name suggests, row matrix is something which has only rows. So a matrix that contains only one row. So this is a row matrix. 1, 2, 4, 7. So you can see there is only row, there is only one row. There is only one row and there are multiple columns. There are 1, 2, 3 and 4 columns. So there is one row and 4 columns. So since there is only one row, this will be a row matrix. So it has the order 1 cross n. So number of rows is 1 and number of columns is 1, 2, 3 and 4. So the order of this matrix is 1 cross 4. So the order of this matrix is 1 cross n, where n is the number of columns. Here the number of columns is 4, so the and the number of rows is 1, so the order of this matrix will be 1 cross 4. Then we have column matrices. So column matrices, as the name suggests, a matrix that contains only one column. The column matrices is like this: 1, 2, 4, 7. So you can clearly see there is only one column. There is only one column, so this is a column matrix. Now the order of this is m cross 1. It is represented as m cross 1, where m represents the number of rows. So m cross 1, where m represents the number of rows. So this is first row, second row, third row and fourth row. So number of rows is equals to 4, and since this is a column matrix, so it will be m cross 1, where m is equals to 4. So the order of this matrix will be 4 cross 1. Order of this matrix will be 4 cross 1. Then we have square matrix. So square matrix, as discussed in the previous slide, it is a matrix which has equal number of rows and columns. The same number of rows and columns. So square matrix is the same number of rows and columns. The square matrix is represented as the order of square matrix is written as n cross n, where n represents the number of rows or number of columns. Let's say if we have a matrix of 3 cross 3, that is 3 rows, 3 rows and 3 columns. So A11, A12, A13, A21, A22, A23, A31, A32, A33. So you can clearly see there are 3 rows, 1, 2 and 3, and 3 columns, 1, 2 and 3. So number of rows and number of columns are same. So this is a square matrix. Again, if I say there is a 2 cross 2 matrix, so 2 rows and 2 columns. So this is A11, A12, A21 and A22. So this is also a square matrix. The square matrix of order 2 cross 2, that is this one, and 3 cross 3, that is this one. This is generally discussed, like majority of the questions are formed on these matrices only, on 2 cross 2 matrix and on 3 cross 3 matrix. So understand this very clearly. These matrices, how they are how they are drawn, how a 3 cross 3 matrices are drawn. So A11, so 3 cross 3, and it is 2 cross 2 matrix. So this is a square matrix. Then we have a diagonal matrix. So what is exactly a diagonal matrix? So diagonal matrix is a square matrix. So it is a square matrix of order, let's say 3 cross 3, 2 cross 2, or n cross n, or 4 cross 4, 5 cross 5, in which all non-diagonal elements are 0. What are diagonal elements? So if I say this one, if this is 9 elements of the matrix 3 cross 3, so these are the diagonal elements. These 3, this one, and this one, these are the diagonal elements as we discussed while we were calculating the trace of matrix. Trace of matrix is sum of all these elements. So these are the diagonal elements. What a diagonal matrix says, that all non-diagonal elements are 0. So which means except these 3 matrices, except these 3 elements, these values will be 0. these values will be 0. So if I have to write how a diagonal matrix will look like, so diagonal matrix will be something like 1 0 0 0 2 0 and 0 0 3. So you can clearly see that the diagonal elements are non-zero, and all the non-diagonal elements, that is this one and this one, or this one or this one, these all are 0. Only the diagonal elements are non-zero. So it is saying the same thing, square matrix in which all non-diagonal elements, that is these two and this one and these two and this one, these are 0. So this is a diagonal matrix. Then we have 0 or null matrix. A 0 matrix or null matrix is a matrix in which all the elements are 0. It can be of any order. So a 0 matrix is something which has all the elements as 0. So 0 0 0 0 0 0. So this is a 0 matrix of order 3 rows and 2 columns. So 3 cross 2. 3 rows and 2 columns, 0 0. So all the elements are 0 of this matrix. So this is a 0 matrix. So 0 matrix is something in which all the elements of the matrices are 0. It is generally represented by 0. This is a general representation of all the of all 0 matrices of all the orders. So 2 cross 3 or 4 cross 5 or any particular order, the 0 matrices is represented by this O like symbol. Then we have identity or unit matrix. So identity or unit matrix. So identity matrix is a square matrix with ones on the main diagonal, ones on the main diagonals and zeros everywhere else. So if let's say it is, first of all it is a square matrix, so it is of order n cross n. Now let's say I have a 3 cross 3 matrix, so 3 cross 3 again. So what exactly is a identity matrix is 1 0 0 0 1 0 and 0 0 1. So it is a identity, it is a diagonal matrix kind of thing in which all the diagonal elements are 1 and all the non-diagonal elements are 0. So this is a identity matrix of 3 cross 3. It is represented by I of n, In. So where n represents the order. So this is I3. This is I3. If I say what is I2, I2 is 1 0 0 and 1. This is I2. Then if I ask what is I4, so I4 will be 1 0 0 0 0 1 0 0 0 0 1 0 and 0 0 0 and 1. So I4 is a 4 cross 4 square matrix in which you can see all the diagonal elements are 1, main diagonal elements are 1 and other elements, all the elements which are not diagonal, so they are 0. So you can see all these elements are 0. So this is what, this is I4, a 4 cross 4 matrix with all the diagonal elements as 1 and non-diagonal elements as 0. So this is identity matrix. N cross n is the order of the matrix. It acts as multiplicative identity. What this means is basically any matrix multiplied by I will give you the same matrix. So if I say matrix A and if I multiply this matrix by an identity matrix of same order, so A into I will give me A only. A into I will give me A only. Let's say we have another matrix of B. B into I will be again B. So any matrix which is multiplied by identity matrix will give me the same matrix only. So B into I will be B. If I have to prove you this as well, when I'll teach you the matrix multiplication, there I'll prove you. So this is identity matrix. Then we have triangular matrix. So triangular matrix is a square matrix. So triangular matrix is a square matrix where all elements above or below the main diagonal are 0. All elements above or below the main diagonal are 0. So if I have to just modify this thing, so these are of two types. First of all, One is upper triangular matrix, so all the elements below the main diagonal are 0. So if I say this is 1, 2 and 4, and let's say this is 3, 1 and 5. So all the elements below the main diagonal. So this is the main diagonal, and all the elements below the main diagonal will be 0. That is, this one is 0, this one is 0 and this one is 0. So all the elements below the main diagonal. So main diagonal and below the main diagonal, all the elements 0. This is upper triangular matrix. This is upper triangular matrix. What is lower triangular matrix? All elements above the main diagonal are 0. So for upper triangle, below the main diagonal are 0, and for lower triangle, above the main diagonal are 0. If I have to give it in this one, so the lower triangular matrix will be, let's say 1, 2, 3. This will be 4, 5 and 6, and this is a diagonal, and all the elements above the diagonal will be 0. All the elements above the main diagonal are 0. So this element will be 0, this will be 0 and this will be 0. So now this is lower triangular matrix. This is lower triangular matrix. So we have upper triangular matrix and lower triangular matrix. Then we have scalar matrix. So scalar matrix is again a modified form of diagonal matrix. So scalar matrix is a diagonal matrix where all diagonal elements are equal. So if I have to just tell you about the 3 cross 3 scalar matrix. So this is, if I say, what it is saying is all diagonal elements are equal. So this 3, 3 and 3, all the diagonal elements are equal, and it is a diagonal matrix. So any elements other than the diagonal elements will be 0. So this will be 0, 0 and 0, 0, 0 and 0. So this is a scalar matrix. This is a scalar matrix. This is a scalar matrix. All the diagonal elements are equal and all the non-diagonal elements are 0. All these non-diagonal elements are 0. Now, identity matrix is also a special form of scalar matrix only. You can see all the elements are equal, diagonal elements are equal, and all the non-diagonal elements, that is this one and this one, is 0. So identity matrix is also a scalar matrix only. So this is regarding the types of matrices. If you have any doubt, you can ask. Okay, so let's move to the next slide. So this is a question. You have to calculate the trace of the matrix. Give this a try. So again, what was trace? Trace was sum of diagonal elements. And what were the diagonal elements? All the elements of the, all the diagonal elements of the matrix, you have to sum them, and you have to, that will be your trace. Now in this you are given the trace, and you are given an equation which you have to solve. So try this one. Correct, Joshua? It is C. So the time is up. So let's discuss about this one. So it is given that if the trace of the matrix, A, this is the matrix, is 7. So trace of matrix A, TR of A is equals to 7. Then which of the following is not a possible value of x? Which of the following cannot be the value of x? So first of all, what exactly is a trace? Trace is sum of diagonal elements. Sum of diagonal elements. What are the diagonal elements? This x cube is a diagonal element, then which is first row and first column. Then we have second row and second column. So A11, then we have A22. It is sigma AII from I is equals to 1, I is equals to 1 to I is equals to n. So this is trace formula. Sigma of AII, which is I equal to 1 to I equal to n. Here n is equals to 4. So it is a 4 cross 4 matrix. So what will be the trace? Trace of A will be A11 plus A22 plus A33 plus A44. So A11 is the element of first row and first column. A22 is second row, second column. A33 third row, third column, and A44 fourth row, fourth column. So x cube is A11. So this is x cube. Then second row and second column is this one, which is 2x square. So x cube plus 2x square. Then third row and third column is 3 minus x. So plus 3 minus x plus fourth row and fourth column, this is 2. So plus 2. So this is the trace, x cube plus 2x square plus 3 minus x plus 2. And this is equals to what? This is given as 7. So trace of matrix is given as 7. So this is equal to 7. Now we have a cubic equation. We have to solve this one. What we'll do, we'll take 7 this side. So it will become x cube plus 2x square plus 3 plus 2, 5 minus x minus 7. This 7 will become minus 7 and this is equal to 0. So the equation will become x cube plus 2x square minus x minus 2 equal to 0. Now this is a cubic equation. Again, either you can put the values and do a hit and trial with x equal to 1, x equal to 2, minus 1, minus 2. One of them value will be satisfied. Or you can do one more thing. You can just take x square common here. So this x square common will be, x square will be common, and this in the bracket it will be remaining x plus 2. X square into x plus 2. And here you just take minus 1 common. You just take minus 1 common. So this will be minus 1 into x plus 2 equal to 0. Now this is x plus 2, this is x plus 2, we can combine them. So this will become x square minus 1 into x plus 2 equal to 0. Now x square minus 1, it is like a square minus b square. It can be written as a minus b into a plus b. So this can be written as x minus 1 into x plus 1. This x square minus 1 can be written as x minus 1 into x plus 1 multiplied by x plus 2 equal to 0. So the value of x can be either 1 or minus 1 or minus 2. So the value of x can be either 1 or minus 1 or minus 2. The question is asking which of the following cannot be a possible, is not a possible value of x. So we have seen that 1 is a possible value of x, minus 1 is a possible value of x, minus 2 is also a possible value of x, 2 is not possible. Thus, our correct answer will be C, which is 2, that it is not a possible value of x. If you have any doubt in this one, you can ask. Why, Keeta, you said 1? 1, as I proved it to you, this is a possible value of x. You have to solve the cubic equation and you will get 3 values of x. If you have any doubt regarding this solution, you can ask. Okay, so let's move to the next slide. So now we have another important topic, which is matrix addition. So matrix addition is the process of adding two matrices. Adding two matrices elements. element wise. So you have to take the element of each matrix and you have to just add up. So in two matrices, one very important condition, two matrices can be added only if they have the same order. That is, you can add a 2 cross 2 matrix. You have a matrix of 2 cross 2 to another 2 cross 2 matrix only. It is not possible that you are adding, let's say 2 cross 3, 2 rows and 3 columns. Let's say this is 2 rows and 3 columns. So this is a 2 cross 3 and 3 rows and 2 columns. So 3 cross 2 matrix. 3 rows and 2 columns. So 3 cross 2. So these two matrices cannot be added. This is not possible. You have to add the matrices of the same order, and also it should be a it can be of any order, but the order should be same. If it is 2 cross 3 first matrix, the second matrix should also be 2 cross 3. If it is any other order, it won't be addable. So one very important condition for adding the matrices is basically the order should be same. Order of the matrices should be same. That is, it should be of order n cross n for both the matrices, or let's say if there are 3 matrices which we are adding, all 3 matrices should have the order n cross n. Then if A is equals to Aij, that is A11, A12, A21 and A22, and B is equals to Bij. So B11, B12, B21 and B22. Let's say we are discussing about 2 cross 2 matrix. So A plus B will be Aij plus Bij. So A plus B will be A11 plus B11. Then the second element, that is first row and second column, will be A12 plus B12. Then second row, first column will be A21 plus B21. And second row, second column will be A22 plus B22. Let's understand this with this example. So we are given two matrix A and B. So A is 3 minus 1, 2 and 4, and B is 1, 5 minus 3 and 2. We have to perform A plus B. So what we have to do, we have to add A11, that is the element of first row and first column, with the element of first row and first column of the second matrix. So this one. So this becomes 3 plus 1. First row, first column, first row, first column. Both the element of the matrices take together and add them. Then first row, second column, that is minus 1, and first row, second column, that is 5. So minus 1 plus 5. So we are adding the element, the corresponding element of both the matrices. First row, second column, first row, second column. Then we have second row and first column. So second row and first column. And for the second matrix also, we will take second row and first column. So 2 plus minus 3. So 2 plus minus 3. Then we have second row and second column, which is 4 for the first matrix, and second row, second column for the second matrix, which is 2. So 4 plus 2. So A plus B will be 4, 4, minus 1 and 6. So 3 plus 1 is 4, minus 1 plus 5 is 4, 2 minus 3 is minus 1, and 4 plus 2 is 6. So this is A plus B. Similarly, if I ask you what is A minus B, you have to repeat the same process. If it is matrix, not matrix addition, it is matrix subtraction, you have to repeat the same process. Again, A minus B will be what? Aij minus Bij. That is A11 minus B11. So A11 minus B11 is 3 minus 1. So A11 is 3 and B11 is 1. So 3 minus 1. Then A12 is minus 1 and B12 is 5. So minus 1 minus 5. So this is matrix subtraction. Then A21 and B21. A21 minus B21. So this is 2 minus minus 3. Then we have A22 minus B22. So this is 4 minus 2. So A minus B will be matrix A minus B. When we are subtracting matrix B from matrix A, it will be 3 minus 1 is 2, minus 1 minus 5 is minus 6, 2 minus minus 3 is 2 plus 3, which is 5, and 4 minus 2 is 2. So 2 minus 6, 5 and 2. This is your, this is how you subtract the matrices. So the process is very simple. You have to take the corresponding elements of all the matrices. Let's say if there is one more matrix of 2 cross 2 order only, C. which says 2, 3, 4 and 1. So the 4 elements are 2, 3, 4, 1. And if they now ask you for A plus B plus C, you have to do nothing. You have to just take the corresponding element of all the 3 matrices. So A plus B plus C, what we have to do? We have to first take first row, first column element of all the matrices. So 3 plus 1 plus 2 will be the first row, first column of the A plus B plus C. So this will be 3, 1, 2, which is 6. Then we have minus 1 plus 5 plus 3. First row and second column. So minus 1 plus 5 plus 3 is 7. Then second row, first column. Second row, first column is 2 in A, minus 3 in B, and 4 in C. So 2 minus 3 plus 4. So again 2 plus 4, 6 minus 3 is 3. Then second row, second column, in A it is 4, B it is 2, and C is 1. So 4 plus 2 plus 1 is 7. So this is A plus B plus C if C is this matrix. You have any doubt regarding this addition of matrices, you can ask. Hi Math Magic. So let's move to the next slide. Now properties of addition of matrix. First of all, addition, again a very important point. It is defined only when the matrices have the same order. Matrices have the same order, that is 2 cross 2. All the matrices should be 2 cross 2. Then we have, if the matrices is 3 cross 3, then all the matrices which we are adding or subtracting should be 3 cross 3 only. So the matrices should have the same order. Then it is commutative, that is, if you add matrix A plus B and B plus A, the result will be same. If you add matrix 1 to matrix 2 or matrix 2 to matrix 1, it will give you the same result. So they are commutative. Then we have associative property also being followed, that is A plus B plus C is equals to A plus B plus C. This is the associative property which is also followed by matrices. Matrix addition. Then it also follows additive identity, that is if you add any zero matrix, this is a zero matrix, so O represents the zero matrix. If you add any zero matrix to any matrix, the result will be same. So A plus 0 is equals to 0 plus A, and both of them will be A only. Both of them will be A only. This is the additive identity. A plus 0 is equal to 0 plus A because they both follow commutative property, and it is equal to A only. Then matrix minus A. So if we have A, and if we multiply all the elements, let's say if A is 1, 1, 2, 3. If we multiply all the elements of matrix A by minus 1, we will get minus A. So minus A will be minus 1, minus 1, minus 2 and minus 3. So this is A, this is minus A. So matrix minus A is the additive inverse of A. What do you mean by additive inverse? Like if you add the additive inverse into the original element, the result will be 0. So A plus minus A will be equal to 0. A plus minus A is equal to 0. If you add these elements 1 and minus 1, this will be 0. 1 and minus 1 again 0. 2 and minus 2 again 0. 3 and minus 3 again 0. So the sum of A plus minus A will be 0 only. So it is a 0 matrix. So these are properties of addition of matrix. If you have any doubt, you can ask. So we have 12 people watching in, and we just got 9 likes. I'll request you to like this stream. It is a motivation for all of us. We are doing this for all of you, and we are doing this for free. So it is just your one like will give us a lot of motivation to keep continuing this. Also, again reiterating this thing, we have these classes up till the exam date, which is I think is 13th of December. So up till 13th of December, we have the entire schedule as discussed in this slide. These are the classes for the next 4 days. we have this schedule up till 13th, schedule prepared for up till 13th of December. So we have a lot of good topics which are discussing on a daily basis. So I'll definitely suggest you to subscribe to the channel and join the WhatsApp group as well. Any updates from IIM Bangalore, whatever we are receiving, we are updating either on our YouTube channel or we are updating on the on our WhatsApp channel. So subscribe to this channel as well as join the WhatsApp channel as well for more updates. Yeah, Kieta, yes, the method for addition of 3x3 matrix is also same. I'll just take one example. So let's say you have a 3x3 matrix of 1, 1, 2, 2, 1, 3 and 0, 1, 2 plus 2, 1, 1, 3, 1, 2 and 0, 2, 3. So again, you have to do the same thing. Add the corresponding element of both the matrix. So first row, first column and first row, first column, add them. So this will be again, if you're adding two 3x3 matrix, you will get a 3x3 matrix only. Add first row, first column element of both the matrix. So 1 plus 2 is 3. Then first row, second column and first row, second column. So 1 plus 1 is 2. Then first row, third column and first row, third column. So 2 plus 1 is 3. Then second row, first column and second row, first column. So 2 plus 3 is 5. Second row, second column and second row, second column is 1 plus 1 is 2. Then third row, second row, third column, second row, third column. So 3 plus 2 is 5. Then third row, first column, 0 plus 0 is 0. Third row, second, 1 plus 2 is 3. And third row, third column, element is 2 and 3. So 2 plus 3 is 5. So this is the procedure for adding 3x3 matrix. It goes for same 4x4 matrix as well, 5x5, 6x6 or 7x7, 8x8. You just have to take the corresponding row as well as corresponding column element and you have to just add them. So let's move to the next slide. Now we have one again very important topic which is matrix multiplication. So matrix multiplication is defined as the product of rows of the product of the rows of the first matrix with the columns of the second matrix. Rows of the first matrix to the columns of the second matrix. So let's say if you have two matrices of order A m cross n, you have one matrix of say m cross n order and another matrix of say order p cross q. So these are the orders of two matrices. One is m cross n, let's say one is 2 cross 3 and another is 4 cross 5. So if you have two matrices of m cross n and p cross q order, then the product of matrices AB, the product of both the matrix AB is defined only if n is equals to p. That is this n and this p, that is the number of columns of the first matrix and number of rows of the second matrix should be equal. Now in this I can see there are 3 columns in the first matrix and 4 rows in the second matrix. So these two multiplication is not possible. It is only possible when the number of columns of the first matrix is equal to number of rows of the second matrix. So which is possible? The matrix multiplication is defined. Let's say if this is a matrix A is of order 2 cross 3 and matrix B is of order 3 cross 4. So if matrix A is of 2 cross 3 and B is 3 cross 4, you can clearly see the number of columns of first matrix is equals to number of rows of the second matrix. So number of columns of first matrix equal to number of rows of second matrix. So since they are equal, they both are the product of these matrices are possible. In this, the first case which was 2 cross 3 and 4 cross 5, the product was not possible because 3 was not equal to 4. So another important condition, it is possible only when n is equals to p or the number of columns of the first matrix is equal to number of rows of the second matrix. Then if multiplication is possible, then C is equals to ABB will be a matrix of order m cross q. So if it is let's say 2 cross 3 which is m cross n and 3 cross 4 which is p cross q. Now we see that this n and p is 3 and 3. N is equal to 3 and p is equal to 3. Now both n and p are equal. So product is possible. So the product will be AB. And what will be the order of this matrix? Order of this matrix, that is this newly formed matrix, let's represent it by C. C is equals to AB. So C is equals to AB is equals to will be 2 cross 3 cross 3 cross 4. This will be 2 cross 4. 2 cross 4, that is M cross Q. Number of rows of first matrix cross number of columns of the second matrix. So this will be the order of matrix of product of the matrix. So AB is 2 cross 4. Then we have how to multiply these matrices. I'll discuss it in the next slide. So this is Cij is equals to Aik into Bkj. Ik is equals to 1 to n. N is here the order of matrix. N is the order of matrix. Then we have one more thing. I'll discuss this thing in the next slide. How to exactly do the multiplication of matrices. Then we have scalar multiplication. So scalar multiplication means multiplying each element of a matrix by a real number or a scalar quantity. So if let's say I have a matrix of 2, 1, 3 and 4. This is A. Now I have to do a scalar multiplication. I need to find the value of 3A. If A is 2, 1, 3, 4, what will be the value of 3A? What you have to do is basically you have to multiply this matrix by that same scalar what we have to find. So we have to find 3A. So what we will do, we will multiply all the elements, this 2, 1, 3 and 4 with this 3, with this scalar quantity. All these elements will be multiplied by 3. So this will become 2 into 3 will be 6, 1 into 3 will be 3, 3 into 3 will be 9 and 4 into 3 is 12. So the value of 3A, if A is 2, 1, 3, 4, matrix 3A will be 6, 3, 9 and 12. If I say B is equal to 3A, B is another matrix which is thrice of A. So B will be what? 6, 3, 9 and 12. So this is a scalar matrix, scalar multiplication. You have to do nothing. You have to just multiply each element by that scalar quantity of the each element of the matrix by that scalar quantity to get that to do the scalar multiplication. So if you have any doubt, you can ask, or should we move to the next slide, which is how to multiply two matrices. So let's move to the next slide. So I have taken an example of how to multiply the matrices. So I have taken two matrices A and B. So A is this one 3, 1, 4, 0, 2, 3, 1, 4, 2 and B is 2, 0, 1, 4, 3, 2 and 1, 1, 4. So how exactly to do is basically this formed as there Cij k equal to 1 to n Aik into Bkj. So if I say C is equals to AB, each element of C will be Cij and this is represented by summation of Aik into Bkj, k equal to 1 to n. So first of all, n is what? N is the order of matrix. Here n is 3, n is equal to 3. Let's say I have to find the C11 value. C11 value, that is I have to find the value of C11 first row and first column. C1 will be 11 will be what? Sigma k is equals to 1 to 3. K is equals to 1, 2 and 3. So there are three values for k because n is 3. So C k is equal to 1 to n, n is 3. So this is the thing. Now I value is 1. Cij we have to find, that is we have to find the value of first row and first column element of C. So I is 1, so this one will be A1k and this one will be Bkj. So J is again 1. So this will be Bk1. Bk1. Now what we'll do, we'll add the elements. We'll substitute the value of k. That implies C11 will be first k is equal to 1. So A11 B11. Then k will be 2 plus A12 B21. A12 B21 plus k will be 3 then. K is equal to 1, k is equal to 2 and k is equal to 3. So this will be A13 and B31. So this is the element of first row and first column in the matrix multiplication. So what is this? This is A11 into B11. So A11 is this one and B11 is this one. Then A12 into B21. So A12 which is first row and second column. So A12 is this, and B21 second row and first column. So this. A13 is this one, first row and third column. So A13 is 4, and B31 is third row and first column. So this is 1. So what exactly you have to do is basically C11 will be 3 into 2 plus 1 into 4 plus A11 into B11, A12 into B21, A12 B21, and A13 B31. So plus 4 into 1. So this will be 3 into 2 is 6 plus 4 10 plus 4 14. So C11 will be 14. So what I meant to say is C11 is 14. So let me just erase this one. So if I have a matrix C, again it is, first of all, this is 3 cross 3 matrix, and this is also 3 cross 3 matrix. So we can say if it is M cross N and P cross Q, I can say N and P are equal. N and P are equal, which is equal to 3. So the order of this final matrix will be M cross Q. When we will do the product, when we multiply A by B, C is equal to AB, what this will be? This will be a matrix of 3 cross 3, that is, there are 3 rows and 3 columns. So I will represent it by this one now to be easily understood. So this is a matrix of 3 rows and 3 columns. So 3 rows and 3 columns. As discussed, C11 is 14. C11 is 14. So this element is 14. Now in this thing Cij, what I'll do, I'll put I is equal to 1 and j is equal to 2. So this will be, we are finding for C12. So C12, again sigma A1k and BK2. Again I is 1 and j is 2. So A1k, BK2. So k is equals to 1, say 3. So C12 will be A11 into B12 plus A12 into B22 plus A13 into B32. Right? If I substitute the value of k as 1, 2 and 3 and summation, we will do, this is a summation symbol, we have to add all the elements. So A11 into B12, A12 into B22 and A13 into B32. So what exactly does this mean is A11, so A11 is 3. A11 is 3 and B12 is first row and second column, so 0. So this is 3 into 0 plus first row and first row second column of the element, first row second column, that is A12 multiplied by B22, second row and second column. So this is 3. So 1 into 3. Then A13 is first row third column, which is 4 multiplied by second row and third row and second column, A B32, which is third row and second column. So 4 into 1 plus 4 into 1. So this will be 3 into 0 is 0, 1 into 3 is 3 and 4 into 1 is 1. So this will be equal to 7. So first row and second column element of matrix C, that is after doing the product, will be C12, which is 7. Now you don't have to do this all the time. What you have to do is basically now you have to find the value of C13, that is this one. Okay. C13, first row and third column, you have to find out this value. So what you will do, you will take the first row of first matrix and third column of the second matrix. So first row is 3 1 4 and third column of the second matrix is 1 2 4, and you will multiply each corresponding element. So this is 3, you will multiply the first element of the column. Then second element of the row, you will multiply with the second element of the column. So first element of the row multiplied by first element of the column, second element of the row, second element of column, and third element of the row multiplied by third element of the column. So this will become, so C13 will be First row, we will take the row as 3, 1 and 4. So first element is 3 into first element of the column is 1, this one. Then second element of the row is 1. So 1 into second element of the column is 2. So 1 into 2. Then third element of the row is 4. Third element of the row is 4 and third element of the column is 4. So plus 4 into 4. So 3 into 1 plus 1 into 2 plus 4 into 4, this is equal to 21. 3 plus 2 plus 3 plus 2 5 and 4 into 4 16. 16 plus 5 21. So this will be 21. Now we have to follow this thing for the same for all the other elements as well. You have to just see what we have to find out. Now we have to find the value of this one. This is what? This is C21. C21, second row and first column. So what we'll do, we'll take the second row of the first matrix and first column of the second matrix. For this we'll take the row and this will take the column. So second row of the first matrix and first column of the second matrix, and we'll multiply the corresponding element. So what we'll do, we'll multiply, second row is this one and first column is this one. So what we'll do, we'll multiply this 0 by this 2, first element by first element. So 0 into 2 plus 2 into 4, second element of the row multiplied by second element of the column. So 2 into 4 plus third element of the row multiplied by third element of the column. So plus 3 into 1. So 0 into 2 is 0, 3 into 4 is 8 and 3 into 1 is 11. 3 into 1 is 3, so 8 plus 3 is 11. So this element will be 11. C21 will be 11. Now this is C21. Now what we have to do? We have to find the value of C22. We have to find the value of this one, which is C22. This means we have to take the second row of the first matrix and column 2 of the second matrix. So second row of the first matrix is this one, and second column of the second matrix is this one. So what we have to do, we have to again multiply the corresponding element. First element multiplied by first element, so 0 into 0 is 0, plus 2 into 3 is 6, plus 3 into 1 is 1, 3 into 1 is 3. So 0 into 0 is 0, plus 2 into 3 is 6, plus 3 into 1 is 3. So this will be equal to 9. So this element will be 9. Now what we have to do, we have to find the second row and third column element. For the product of AB, we have to find the value of second row and third column. What is second row? Second row is this one. What is third column? Third column is change. Now, this is my third column. Again, same process. First element, first one, second one, and third one. So 0 into 1 is 0. 0 into 1 is 0. Plus 2 into 2 is 4. Plus 3 into 4 is 12. So 0 plus 4 plus 12, this will be 16. So this is C23. Now let's find out C31. Let's find out C31. Again, what does C31 means? You have to find the value of this one. So this is C31. So C31 is third row and first column. Third row of the first matrix is this, and first column of the second matrix is this. So third row and first column. Now 1 into 2 is 2, 4 into 4 is 16, and 2 into 1 is 2. So 2 plus 16 plus 2, which is 20. Then what we have to do, we have to find the value of C32. So what is C32? Again, third row of the first matrix, so third row of the first matrix, and second column of the second matrix, C32. So C32 is third row of the first matrix and second column of the second matrix. So again 1 into 0 is 0, 4 into 3 is 12, and 2 into 1 is 2. So 0 plus 12 plus 2, which is 14. Now we have to find the C33 value. So C33 value is again third row of the first matrix. So third row of the first matrix and third column of the second matrix. Third column of the second matrix. So this is 1 into 1, 1 plus 4 into 2 is 8. 1 plus 8 plus 2 into 4 is 8. So 1 plus 8 plus 8. So this is 17. So this is how you form the find the product of matrix. So if I have to say C is equals to AB, this will be equal to 14, 7 and 21, 11, 9, 16 and 20, 14 and 17. So this is how you find the product of the two matrices. If you have any doubt, you can ask. So let's do a question on this one. So I'm posting a question. Just try this one. Okay. Just put the values of n and you will find the like basically a pattern which will be following. So a square will be a into a cube will be a square into a, and a to the power 4 will be a cube into a. So first you have to find the value of a square, then for a cube multiply this matrix with the original a matrix, then you will get the value of a cube. Then for a4 you multiply this matrix which is a cube by the original matrix which is a. Good, Bhavna. The time is up. Let's discuss this one. This is a difficult question, not an easy one. You have to get the first of all you have to find the pattern, what exactly is the pattern, and then you have to subtract n times of I. Also I is the identity matrix. I is the identity matrix. So this side, okay. So I is the identity matrix. So if A is equal to 3, 2, 0, 1, it is a 2 cross 2 matrix, and Bn is equals to a to the power n. So Bn is equals to a to the power n minus ni. Again, I, you don't have to, you cannot put that out, you cannot ask this thing that what is the order of I. You cannot ask what is the order of I, because as I said, the addition or subtraction of matrices will be done on the same order. So the order of I will be 2 cross 2 matrix only. So order of I will be 2 cross 2. So this is a 2 cross 2 matrix. So this is I2, 1, 0, 0 and 1. This I is basically this I2. This can be only 2 cross 2 matrix only, because your first matrix is 2 cross 2. And all the subsequent matrix, like if you find out a square, a cube, a to the power 4, a to the power 5, or all of these matrices will be a 2 cross 2 matrix. So Bn is equal to a to the power n minus ni. Then what is the value of B4? So what we'll do, first we'll find out, we will see what is B1. So B1 is a minus ni. Then what we'll do, we have to find B2, which is a square minus n, a square minus, so this will be I. So B2 will be a square minus 2i. Again B3, it will be a cube minus 2i. And B4, this will be a4 minus, a cube minus 3i and a4 minus 4i. So this is what we have to find out. So we have a, first of all we have to find the value of a square, because ultimately we have to find the value of a to the power 4. So what is a square? A square is a multiplied by a. A square is a multiplied by a. So this will be 3201 multiplied by 3201. Again you can see number of columns of the second matrix is number of rows of the first, number of columns of the first matrix is equal to number of rows of the second matrix. So multiplication is possible. Basically n is equal to p is equal to 2. Multiplication is possible, and the order of the final matrix will be 2 cross 2 only, which is m cross q. So first of all m cross n is 2 cross 2 and p cross q is 2 cross 2, same thing. So matrix will be same only. So 3 2 and 3201 multiplied by 3201, it is a 2 cross 2 matrix only. What we have to do, first we have to find the value of C11, a square, first row, first element. First we have to find this value, then this one, then this one, and then this one. So what will be this value? This is first row, first column. So what we have to do, we have to take first row of first matrix and first column of the second matrix, and we have to multiply the corresponding element. So this will be 3 into 3, which is 3 into 3 is 9, and 2 into 0 is 0. So 9 plus 0, so this element will be 9. Then we have 1 2, which is first row and second column. So now we have to take this first row, and instead of this column we have to take this second column. We have to take this second column for A12. So again 3 into 2 plus 2 into 1. So 3 into 2 is 6 plus 2 into 1 is 2. So 6 plus 2 is 8. Now we have to find out 2 1. So 2 1 is second row of the first matrix and first column of the second matrix. Second row of the first matrix and first column of the second matrix. So 2 1. So 2 1 will be 0 into 3. So 0 into 3 is 0 plus 1 into 0. So 0 into 3 is 0, 1 into 0 is 0. So 0 plus 0 is 0. So this element will be 0. Then we have to find out A22. So we have to find the value of second row and second column. So what we'll do, we'll take second row and second column, and we'll multiply the corresponding element. So this will be 0 into 2 is 0 and 1 into 1 is 1. So 0 into 2 is 0 and 1 into 1 is 1. So this will be 1. So this is my a square. This 9801 is my a square. Now what I have to do, I have to find the value of a4. A4 will be what? A square into a square. So what this will be? This will be 9801 multiplied by 9801, because A4 is a square into a square. So this is your a square matrix. So you have to multiply this matrix twice. Again, now I'll get again a 2 cross 2 matrix only. I'll get a 2 cross 2 matrix. Why? This is 2 cross 2, this is 2 cross 2. This and this value is same, and order of the now if these values are same, I can do the multiplication, and order of the final matrix will be this one, 2 cross 2 only. So it will be a 2 cross 2 matrix. So I have to find 4 values, this one, this one, this one, and this one. So A11 is take the first row and first column, first row of first matrix and first column of the second matrix. So 9 into 9 is 81 and 8 into 0 is 0. So 9 into 9 is 81 and 8 into 0 is 0. So 81 plus 0 is 0. Then A12 is first row and second column. First row and second column. So 9 into 8 is 72 plus 8 into 1. So 9 into 8 plus 8 into 1. So 72 plus 8 is 80. Then we have to find the value of A21. Second row and first column. So second row is this one and first column is this one. So 0 into 9 is 0 and 1 into 0 is 0. So 0 plus 0 is 0. So this will be 0. Now we have to find the value of this one, which is second row and second column. So second row and second column, 0 into 8 is 0 and 1 into 1 is 1. So 0 plus 1 is 1. So my value of A4 will be 81, 80, 0 and 1. What is B4? B4 is A4 minus 4i. B4 is equals to A4, A to the power 4 minus 4 times I. What is my I? I is basically 1, 0, 0 and 1. Now secondly, this is a scalar multiplication. So this is asking for 4i. So what we have to do, if I is this, 4i will be, I have to multiply each element of the matrix I by 4. So this will be 4, 0, 0 and 4. So 4i will be 4, 0, 0 and 4. So A4 is 81, 80, 0 and 1 minus 4i is 4, 0, 0 and 4. Now we have to do matrix subtraction. So B4 will be 81 minus 4 is 77, 80 minus 0 is 80, 0 minus 0 is 0 and 1 minus 4 is minus 3. It is asking for trace of B4 matrix. So trace of B4 is sum of diagonal elements. So sum of diagonal element is 77 and minus 3. So 77 plus minus 3. So this will be 74. So trace of B4 will be 74, which is the correct answer. Well done, Joshua. If you have any doubt in this one, you can ask. Let's move to the next slide then. Now another very important topic is basically properties of multiplication of matrix. Properties of matrix multiplication. So matrix multiplication follows a rule of pre-multiply and post-multiply. So what does pre-multiply say? Pre-multiply say that if you have a matrix A, a matrix B, and you are pre-multiplying it by A. So what you have to do is basically you have to take matrix A first and B as second matrix. So this is pre-multiply by A. Pre-multiply by A. What is post-multiply? Again, if you have a matrix B and you are post-multiplying it by A. So what you have to do, your first matrix will be B and your second matrix will be A. So this is BA. So this is post-multiply. Post-multiply by A. So these two are very important. We'll discuss further that AB is equal to BA. It is not necessary. It can be equal. It cannot be equal as well. AB is equal to BA. It is not necessary to be true always. So this can give you a different matrix and this can give you a different matrix. This is pre-multiply by A. You are taking A as the first matrix, or you are multiplying A by B by putting A first. Or post-multiply is you are taking A as the second matrix and B as the first matrix. Now let's discuss the properties. So the first property says that A into B plus C, A into B plus C is AB plus AC. Now you can see this is pre-multiplication. This is pre-multiplication. So A is the first matrix in both the case. So A into B, so this will be AB, and A into C, this will be AC. So AB plus AC. So A into B plus C will be, first you have to multiply these two, which will be AB, and then these two, which will be AC. So AB plus AC. Then we have A plus B into C. Now this C is the post multiplication. So A plus B into C. So now always C will be the second matrix. So first we have to multiply A by C. So this will be AC now, not CA. CA will be different. AC is different. So AC plus then this one. So BC. So AC plus BC. CB is different. CA is different. And since we are doing it post multiplication, so this C will be the second matrix. In the first case, A is the pre-multiplication, so A was the first matrix. So AB plus AC and AC plus BC. Again, so these are the first two properties. Then ABC, it is the associative property. It follows that if we multiply A, BC and AB into C. So what this says that if we first multiply the matrix B and C and then we pre-multiply it by A, it will be equal to if we multiply the matrices A and B and then we post multiply C. So what we are doing is basically we are keeping the order same, that is A, B and C. But what we are doing in the first case, in this one, is basically we are multiplying the B and C, that is the second and third matrix first, and then pre-multiplying it by the A matrix. But in this case, what is happening? We are multiplying the first and second matrix, that is the first two matrices A and B, we are multiplying it, and then we are post multiplying the matrix C. So A and B, we are getting one matrix, and then we are multiplying this matrix by C. So A into BC will be equal to AB into C. So this is associative property. So these are the first three properties. Now let's discuss if AO is equals to O is equals to A, where O is a zero matrix. So if you multiply any matrix by a zero matrix, it will be a zero matrix. So A multiplied by O will be O, and it is same for pre-multiply as well as post-multiply. So this is post-multiplication by zero matrix. If I pre-multiply by zero matrix, so 0 into A, it will again be a zero matrix. So any matrix multiplication, either it is pre-multiply or post-multiply, multiplied by any matrix, any zero matrix multiplied by any matrix will be a zero matrix only. Then fifth property says that it does not follow the commutative property always. It does not always follow the commutative property. That is, it is not necessarily true that AB is equals to BA always. AB is equal to BA, this can be true. This can be true, but it is not necessary that this will be always be true. It is also possible that AB is not equal to BA. Both of these scenarios are possible. There can be a case when AB, multiplication of A and B, will be equal to multiplication of B and A. But this is the other case is also possible when both the products are not equal. AB is equal to BA or AB not equal to BA. So both the cases are possible. So commutative property is not being followed. Associative property is being followed, but commutative property is not being followed. Also, if the product of two matrices is a zero matrix. If a product of two matrices is a zero matrix, it need not imply the statement that either A is 0 or B is 0. That is, if AB is a zero matrix, that is the product of A and B is a zero matrix, it does not imply that either A is a zero matrix or B is a zero matrix. A can be a non-zero matrix and B can be a non-zero matrix, and still it is possible that the product of A and B is a zero matrix. So again, another very important, these two are very important properties of matrix multiplication, that is AB is not equal to BA always, and AB can, if AB is 0, then it is not necessary that A and B, either one of two, is a zero matrix. Then again, another very important property, if I say that AB is equals to AC, in general math operation, what we do is we cancel this one and we say B is equal to C. But in matrix multiplication, this is not possible. It is not necessary, that is, that if I say AB is equal to AC, there can be a case that B is equal to C. But this is not necessary. There can also be a case when B is not equal to C. So if AB is equal to AC, either it can be a case that B is equal to C, or it can be a case that B is not equal to C. But it need not imply that B is equal to C. It is not necessary that if AB and AC are equal, then B and C are also equal. There can be a certain other case when AB and AC equal, but B and C are not equal. So these 7 are the properties of matrix multiplication, with last 3 being a very important one. If you have any doubt in this one, you can ask. Or let me just pose the next question. Okay, so this one. So this is a mixture of first matrix addition as well as matrix multiplication. So time is up. So let's solve this question now. So it is nothing. You have to just, it is a combination of scalar multiplication of matrices, addition of matrices, and multiplication of matrices. So all three concepts which we have discussed are being applied here. So it is given that given the matrices A is equals to 2, 1, 0, 3 and B is equals to 1, 2, 3, 1, what is sum of all elements of matrix C if C is equals to 2A plus B into A plus 2B. So C is equals to 2A plus B, which will be a matrix. This will be a matrix. Let's say this is C1 multiplied by A plus 2B. This is also another matrix. So this matrix is, let's say, C2. So C1 into C2. Now let's, what we'll do, first find out C1. First let us find out C1. So C1 is what? 2A plus B. What is 2A? Again, scalar multiplication. 2A is multiplying all the elements of matrix A by 2. So 2A is 2 into 2, which is 4, 2, 0 and 6. Multiplying all the elements of matrix A by 2. Plus, what is B? B is 1, 2, 3, 1. So 1, 2, 3 and 1. So 4, 2, 0, 6 and 1, 2, 3, 1. You have to add the elements again following the matrix addition now. So 4 plus 1 is 5, 2 plus 2 is 4, 0 plus 3 is 3 and 6 plus 1 is 7. So 5, 4, 3 and 7. So this is our first matrix, which is C1, which is 2A plus B. Then our C2 is this one, which is A plus 2B. So again 2B is basically the scalar multiplication. Now what I have to do is I have to multiply all the elements of matrix B by 2. So my A matrix is 2, 1, 0 and 3 plus 2B will be scalar multiplication of matrix B by 2. So this will be 2, 4, 6 and 2. So now this will be 2 plus 2 is 4, 1 plus 4 is 5, 0 plus 6 is 6 and 3 plus 2 is 5. So 4, 5, 6, 5. Now this is 2A plus B. 5, 4, 3, 7 is 2A plus B and A plus 2B is 4, 5, 6 and 5. So 2 plus 2 is 4, 1 plus 4 is 5, 0 plus 6 is 6 and 3 plus 2 is 5. Now it is asking for C is equals to 2A plus B multiplied by A plus 2B. So it is asking for C is equals to C1 multiplied by C2. What is C1? C1 is 5, 4, 3 and 7 multiplied by C2, which is 4, 5, 6, 5. So 4, 5, 6, 5. Now again C1 is what? 2 cross 2 matrix and C2 is what? 2 cross 2 matrix. So M cross N, P cross Q, again N and P values are same. N is 2 and P is 2. So my final product of the matrix will be a M cross Q will be my final order. So this will be a 2 cross 2 matrix only. Final matrix order will be 2 cross 2. So which means there will be 4 elements. It will be a square matrix and it will be a 2 cross 2 matrix. Now I have 5 into 4, which is 20 and 4 into 6, which is 24. So 5, again I have to find first of all first row and first column element. So what I have to do, I will take the first row of matrix 1 and first column of the second matrix, first row of the first matrix and first column of the second matrix, and I'll multiply the corresponding elements and will add them. So 5 into 4 is 20 and 4 into 6 is 24. So 20 plus 24 is 44. Then we have to find the value of 1, 2. That is, I have to take the first row of the first matrix and the second column of the second matrix. So this will be 5 into 5, which is 25, and 4 into 5 is 20. So 25 plus 20 is 45. 25 plus 20 is 45. Then I have to find the value of 2, 1. So second row of the first matrix and first column of the second matrix. I will consider this one. I will multiply 3 by 4 and 7 by 6. So 3 into 4 is 12 and 7 into 6 is 40. So 42. So 12 plus 42 is 54. Then A22 is basically I have to take the second row and the second column. Second row and the second column. So 3 into 5 is 15. 3 into 5 is 15 and 7 into 5 is 10. 7 into 5 is 35. So 3 5 is 15 plus 35 is 50. So this will be, my final matrix C will be this one. 44, 45, 54 and 50. This is my final matrix C, which is A plus 2B into 2A plus B. It is asking for sum of all the elements of matrix C. So sum of all the elements will be what? It will be 44 plus 45 plus 54 plus 50. So this is 44 plus 45 is 89 and 54 plus 50 is 104. So 89 plus 104 is 193. So sum of all the elements of the matrix will be 193. Thus our correct answer will be option 3, which is 193. Well done, Joshua. If you have any doubt, you can ask in this one. So I think that's it for the today's class, guys. Again, I'll ask you to subscribe to the channel and join the WhatsApp channel as well. Be updated about what we are bringing or what IIM Bangalore is updating about. Like they'll provide their official mock maybe by let's say, I don't know if they've provided it already, or I think they'll be providing it in few days. So whenever they are providing their official mock, we'll update you. We'll update you on the WhatsApp channel. We'll create a video on YouTube as well. So what you have to do, first of all, just subscribe to the channel, to the IIM Cracku channel, as well as join the WhatsApp group. The WhatsApp group link is in the description box. You can check there and join that as well. Basically, interact with all the students who are preparing for IIM Bangalore undergraduate exam. So do subscribe to the channel and do join the WhatsApp group as well. Also, please hit a like button. It provides us the motivation to put on more efforts from our side. We are providing you a lot of free content on our website as well as on this YouTube channel. We are bringing in free classes. We are providing all the content for free. So just one like provides us a lot of motivation to keep continuing doing this. So I'll definitely suggest you to like this channel. Apart from it, do visit the Cracku IIMB. Just search for Cracku IIMB UG mock. Just Google search this. You will have the first link of Cracku. Just click on that link and you will be redirected to this page where you will find 5 free mock tests. As I mentioned it earlier, it is created by the alumni of IIM Ahmedabad, IIM Bangalore and IIM Calcutta. And this is the first year of IIM Bangalore conducting this examination. So I'll definitely, so the best like what they can ask in the examination will be known by someone who has already graduated from these colleges. So basically I'll suggest you to give these mock tests and see where do you stand and what in which topics you are exactly lacking. These are the most probable questions which can be asked in the examination, considering all the other undergraduate examinations for the management tests. So I'll definitely suggest you to give these 5 free mocks, check your scores, see where you are lacking at, and also we are providing you all the classes. We have a schedule up till 13th of December for IIM B UG up till now. Then we will have the schedule for IPMET as well. So subscribe to the channel. Do join the WhatsApp channel as well. Tomorrow we'll discuss about the determinants of the class, determinants of matrices. So that's it for today's, guys. Thank you so much for joining in.